Hello, everybody. This is me again, still working on Tract and on our little project of activation function virtual machine. So I put a link at the top of the main screen, which you can see now. Because this link will point to the page I'm currently editing in GitHub, and as a matter of fact, it starts to be at every beginning of session. It's getting more and more involving to summarize everything that have been done before. So I wanted to put a few links and resources. So first of all the broadcasts have been put on YouTube. Sorry. And the first, there is a playlist dedicated to this specific series of session. And the first and second part are really about what I'm trying to do, and I think they can be watched like 1.5 times or two times speed to understand what I'm trying to do. The next one are more diving into stuff and struggling with Rust macros and assembly and everything. So depending on what you want, there are several options. But what I'm still trying to summarize to give you an overview of what I'm trying to do without requiring to go. Why is it not empty? Okay, that's good. So we are computing activation functions, and when you do neural networks, activation functions are functions that you apply all over a tensor from the first element to the last. So you don't need to know much more about tensor except that they're a big slice of numbers, and you want to apply the same function on each and every element of this tensor and of this slice. And to compute this function, you could do for each in Rust that will just compute a Rust function. But I have the intuition that by making it explicitly vectorized, we can get a significant boost in performance compared to what the Rust compiler on top of LLVM can do on many architectures. So this is what I'm trying to do. So we've defined a small kind of meta assembly language, so kind of bytecode, and that's in the first session. We have like 6 or 7 main activation functions that we want to compute, which makes the first block of relatively easy stuff. Then we have more complicated stuff with sigmoid and hyperbolic tangent, and then we have one also complicated thing, which is exponentiation. So, but for now we are focusing on the first couple of functions, like there are 5 or 6 of them, and essentially they can be computed by using the simple for operations plus min and max. So we got to the point where we have written one part of we have written an assembly function that should be able to compute one of them. So the one we are looking at is called relu, and it's essentially, it's more than essentially, it's literally max with 0. So each value will be replaced by 0 if it's negative, or will not be altered in our function. So if we wanted to write it, to write the function in Rust, it would be x equals max of x and 0. And let's call this y. So that is the one function we are trying to compute. It will be the first one, and then we are going to add more operators to compute our more interesting function. So we have been spending a lot of time struggling with Rust macros because the testing framework in Tract for this function is relatively aggressive, and it relies heavily on macros, so that we can repurpose a test which has been done for one architecture to the other, because we want, of course, we want the functions that we are going to write in assembly, we want them to work on all the architecture that Tract supports. And this architecture includes ARM64, ARM32, some Intel variants. I mean, enough Intel variants to be interesting on Intel. And so we want these test macro to be reusable from one place to the other. And so let's have a look at the macro we are trying, the test we are trying to fix. So, okay, download. And here we are. So, we have a first test here that does that test a no-op function, and the one that we are trying to make work is this one. So it does it performs a max between the value that we want to process and a fixed number which is called alpha. So you can find the x.max alpha here. So this is the reference implementation that we will use to test against. I can see the chat flickering, so I guess my connection once again, yes, my connection dropped and came back. Okay. So one more reason to have a link to the summary page on top of the screen, I guess. I have two. I live in two places, and here I'm in Paris actually, and in this place my connection is bad. I think I need to change the operator box. Anyway, sorry for this. At least on YouTube the full stream should be available. Let me check that everything else is working. Sound seems fine. Okay. Okay, thank you. Thanks a lot and welcome. So this is a test I'm trying to fix, and as you can see on the right, it fails, and there are four. For some reason, there are four. It looks like there are four occurrences of failure, which I'm not sure why. I was expecting just once. But so we have one working and one failing. So the generic is a Rust, because so there is this test reference implementation, but we also have a Rust generic implementation of an equivalent of the assembly function that we wrote in the past couple of weeks. And so this one is working. The one which is not working is that one, which is the assembly one that maybe you saw on the screen a bit before, and that we are trying to fix. I'm trying to figure out why I have four of these, and this is a bit unclear. So let's run the interesting test. The interesting test is this one, and just this one. So it's still failing, and it's failing with these four failures, all happening at the same place. And this place will be very much not interesting, because it will be deep in a macro, I think, 48. Yeah. So this function instantiates both a wrapper around the assembly function that gives a couple of parameters that the function needs to, that the frameworks must be aware of in order to call the function in the right way. So this means that the assembly function can be called for a multiple of 32 elements. and these elements have to be aligned on a boundary of on a multiple of 4 elements. This is to be able to load entire SIMD vector on the ARM64 architecture. Okay, so this is not helping, and the assertion which is failing, I know which one it is, I think, at least. It's because left 1 against 0, I mean it's comparison of 1 and 0, and I suspect that it's not even here. So if you remember what we discussed last time, the prototype for the assembly function that we are writing is the same on all architectures, and it wouldn't have to be the same, but I think it would be the same on most of them anyway. And where is it? It's in frame activations. I think it's there. So yep, because that's a big macro that does everything, and so the function is here that we are trying to implement. So it takes a list of operators that have to be executed, a list of constants that these operators are going to use. So when we do max of 0, the 0 is a constant which is put behind this pointer. This is a pointer to the list of values that we are going to process and change in place. And this is the number of values that we must compute. And we return a use size which can be 0 or 1, and we return a 0. I mean, it's meant to be an error code, so this is where we actually call these assembly functions, and so we assert that the return value is 0. If the return value is 1, then it means something is missing in the function. I mean, usually I use 1 for a bit that is not implemented yet in the assembly function. So here I will just add a comment or kernel function, because it doesn't technically have to be assembly. Kernel function return non-zero. It still doesn't tell me why it pops 4 times, because it should really stop at the first error. I don't have to compile in release. It will be a bit faster if I do like that. Ah, now it recompiles. As a matter of fact, I just saw I think I know at least one of the problems in the assembly that we were looking at before. I saw it this afternoon when I was trying to remember where we were, because it's been a while. It's been nearly 2 weeks. My idea was to stream every Monday night, but life got in the way this week. Okay, so I still have 4. I still have 4 of them. Which is weird. And maybe let me try something. I'm going to try and call the function directly. I mean the executable directly, because here it's called inside QEMU, because I'm running on an Intel and I'm writing assembly code for ARM64. So in this configuration, I'm using a QEMU emulator to run the test. There is another configuration that you can use very easily. But I'm gonna put the release flag back. It's instead of running inside a QEMU, inside the QEMU emulation, I'm going to push the executable to Raspberry Pi 4, which I prepared this afternoon. That's what I was doing this afternoon, actually. And because I want to see if the output comes 4 times, because it is outputted 4 times, or if it's just the test and emulation and stuff that repeat the message 4 times. Because I can see, yeah, it's a bit weird. So now I'm building in release because so it's the build is a bit longer. This is why I was working preferably with QEMU. So the build is a bit longer, but if I don't use release, the binary is so big that it takes ages to be copied to the Raspberry Pi 4. And so I hope that this should get there faster. So far it's not super clear. In the meantime, maybe we can have a look at the function. So it's ARM64 SIMD, and it's ARM64. Oh, yep, it's moving up. Okay, so now we have 4. 1, 2. So we have the panics on top of the rest. 3 and 4. Okay, so that's interesting. Okay, I think, yeah, no, I know what's happening. I think I know. What is happening is we are running the test with prop test. And I think that's what is happening. So prop test is a testing framework that will generate lots of tests and try to figure out the smallest possible test that will trigger the bug. And this is why we get this output over there. Minimum failing input, x equals 0, repeat once, alpha equals 0. So that's the minimal failing input is the prop testing. So prop test found an error, and it tries to change the input to the test. And it found this minimal failing input. And this is what it prints. And the previous ones are just previous attempts by prop test to generate this minimum failing input. So that's yeah, I'm happy with that. That's why we have 4 outputs. Okay. What I usually do when I have a failing test like that prop test found me is I'm making it a standalone test. So here I would make, for instance, I would make a max const with 0, which I could actually call relu. I mean, that's more or less the same than this one. The reason is it's easier to, when you see a list of failing tests, when you put names on the tests, it's easier to get faster to where the problem is. So if I was happy with the way the prop tests are done now, but I'm not, I would probably isolate this failing example in its single unit test. But as I'm not happy with this, and I think we are going to fix it pretty soon, I will leave it alone for now. Okay, so I think what I'm going to do is I'm going to try and fix the assembly function, so we have a starting point which is working with at least one operation. Here we go. So let's have a look at the function. So there are some templating things that I explained last time, and I don't think I'm going to explain it again. But basically, this function, so this is ARM64 assembly, and so this is preserving part of the registers, part of the SIMD register that we must preserve. And so this push their value to the stack. And at the end of the function, we have this instruction that do the opposite. So we restore them exactly as they were before we were called. That's part of the calling convention for this architecture. And unless I got it wrong, which is completely possible, here we have the prototype of the Rust function that we are implementing, or the equivalent Rust function that we are trying to implement. And so the calling convention for ARM64, if I remember correctly, puts the first four elements, the first four parameters of the function in x0 to x3. So x0 will be the pointer to the first operation, x1 will be the pointer to the first constant, x2 will be the pointer to the first value to process, and x3 will be the pointer. X3 will be the number of elements we have to process. So our function starts there. So this is a shortcut. If we don't have any element to process, then we just return quickly. And the OK label, which is implemented here, will put the 0 in x0, which is also used to store the return value of the function. And it will do the register restoration, and it will return. If we have some non-empty slice to process, then we have two levels of loop. First, we have the outer loop, which is basically that. And this loop will loop over the x values in chunk of 32 for architecture. So we will process 32 value at a time. And so at the beginning of the outer loop, we will load 32 F32 values into 8 SIMD registers, because each SIMD registers on this architecture can contain 4 F32 values. So we're loading, so we need 2 instructions to do that. And vectors register V0 to V7, so 7 of them. Each of them contains 4 F32 value. So this is where we're loading the value to process. And in symmetric fashion, this is where we store back this value once they've been processed, once they are no longer X but Y's. This is what puts the value back in the same place in memory. Once we've done this, we can add 128 to the first address that we need to process. We subtract 32 to the number of elements that we have to process. That's x3, which is right there. And if we are not 0, we are jumping back to the outer loop label, which is here, and we're starting again the outer loop over the next 32 values. And actually, this is where it's wrong, because if this is not, if we're done, then we should jump to OK. And I forgot to do this jump last time. So we are doing this, which we shouldn't do, and then going to unsuper. What are we doing then? Then we are jumping there. Anyway, we shouldn't be there in the first place. So what we need to do is once the outer loop is done, we should just jump to the label OK. And that might be the problem. But let me still try to explain what the inner loop is doing. So for every slice of 32 element inside the big slice of element that we are asked to process, we are going to iterate over all the operators in the x0 operator list until we find the zero operation, which means done. And when we found the done operation, we jump to end of inner loop, which is there, that will do the store and try to move along the list. If it's not zero, then it's a real operation that we have to do. And so here I've just tested for max const, which is the one that we are trying to fix. And its opcode is 10 in the current numbering. And so basically, I mean, it's it helps to think of this code in terms of like a virtual machine, because x5 will be our next instruction pointer. So often it's called PC. This instruction is a fetch of this ARM64 loader implements the fetch for our virtual machine, as in we're going to fetch from memory the next instruction, the one pointed by the PC register. So this is decoding. This could be seen as scheduling, or it's not scheduling, but issuing the operation on one port or one ALU, and max count would represent one ALU. And here we are moving the pointer to the next instruction and jumping back to the beginning of the inner loop. So let's see if it's working. So I'm going back to QEMU. Yep. Nope. So we still have kernel function return non-zero 1. The minimum failing input is still the same, so x equals 0 repeated once and alpha equals 0. Okay, so at this point we could try to figure out what is wrong by staring at the code a bit more, or we could go to the Raspberry Pi and try to debug. So let's compile this code for the Raspberry Pi again. Let me try something. I think I can do that, which would probably give us the best of both worlds with relatively fast compilation time and non-massive binary on the Raspberry Pi. The point being, we don't need the symbols because we have to debug assembly, so we are going to debug assembly. Yep. Okay. Okay, so Dingy, which is a tool that I'm using to move code around and move binaries and test around. It's also something that me and my colleague wrote a couple of years ago, actually. Initially it was meant to debug into the same thing with phones. The idea was to enable everybody to test their code easily on their own phone. It's not that easy, but it's helped a lot. So the one we are trying to fix or to run is Trackley 9339AF. track Linux 15, so that's the one. So if I run this executable on the Raspberry Pi with the name of the test, which I will take here, we should have the same error. Okay. And yeah, so that's one of the reasons why I also like to make a unit test. It's because it's a bit, I mean, it's a bit tricky. I mean, it will be fine there, but we will go through function several times, and it would be easier. I mean, it's okay. It won't change anything. So let's install GDB. Okay. Yes. Okay. Okay, so this seems fine. So I want. Oh yes. So I have an error here because running GDB. I mean, you don't put the arguments on the GDB command line, but you put them when you call run in GDB. But before doing that, I need to set a breakpoint. Break, and I will just. I'm going to just break on the function name. So G, I guess, is empty on this architecture, if I remember correctly. So break or not. Okay. So it seems I'm remembering wrong. So let's say. So I was saying before, this is pre-processed by liquid scripts to replace G and suffix and etc. etc. So let's have a look at the output of this. So the file name is hard to predict. So name ARM64 SIMD. That part should be okay. Okay. Underscore act for activation. Okay. So which one? So that's .s. So this is our source file. Target, it could be this one. Target dingy. So no, that's a copy. So dingy does a copy of the source before, because it also sends them to the device. So it has to be one of these two. It doesn't matter really. What I want is, I just want to see a function name that has been generated. Nope, thanks. Up. Okay, so no, it's not expanded here. We still have the assembly, and that's because I did not take the right file. This is the one I want. Here, up. Come here, you. So it's ARM64. Okay, that's good. Let's copy this now. I need the A. I think the copy and paste here doesn't work. Bingo. Okay, so it's break ARM64 SIMD. I'm surprised that completion is not working. Act F32 32N 020 0PR. So that's the version number. Yes. This is not going to work. have a bad feeling about it. Let's see anyway. Nope. Okay. Yeah, it didn't manage to set the breakpoint. Okay. So I'm going to check that the executable contains the function. I can. Maybe the stripping was a bad idea actually, but the function should be there. Really. Okay, let's try this thingy. Try cleanalg 3339, and let's grep ARM64 SIMD because it strings. All right, we have some ARM64 SIMD act. Wow, that's a big wall of text. That's a big wall of text. Let's see. So if instead of using I use this one, and I was gripping act. No symbol, yeah, no symbol because it's a static binary. What am I doing wrong? So I'm going to change. I'm not sure what's wrong. I'm not sure what's wrong, but I'm going to try and compile. I'm going to try and compile for you. I mean, I'm using the muscle toolchain that generates a static binary, and I think maybe it will work better if I'm using the regular GNU targets. So let's try like that. So where's my recipe? My recipe there. Okay, so this is the compilation configuration file. And so what I did is I kept the same device ID, so Raspberry 4, but instead of linking it to the muscle platform, yeah, I did strip the binary, but if I'm stripping the binary, the function name, I mean, stripping shouldn't strip the function name, right? It should strip the debugging symbols. Or am I missing something? I don't remember actually what strip does. But yeah, maybe you're completely right. Maybe that's NM didn't find anything. NM finds stuff, but I mean, it doesn't look like there is any function name in there. So we'll see what it does with the GNU toolchain if it's different. I'm a bit unclear. redelf, yeah. Can try redelf. Do you have any idea what I should run with redelf? I'm looking for the file name. So now we are for BAD. No, actually, okay. We have Sims. Okay. And what if I try with, so this has to be the GNU, yeah, okay, that was the point. I mean, we have stuff. It's not super clear what it is, but at least we have stuff. Let's try the GDB again and see if it's better. So we are going to use for blah blah. Okay, no debugging symbols are found. Okay, so I don't. What if I do break ARM? No completion, so that's not a good. Oh yes, completion. Nope. No completion. It's not. It's not working. So nm thingy tracklinalg for BAD. No symbols. Okay. No symbols, so it's not the toolchain, it's the stripping, I guess. So let's get rid of the stripping. Problem with this is we are going to generate a huge binary and it will take ages to copy to the Raspberry Pi. Off. It will be fine. 186, 96. Oh, I hope I have a big flash card on this Pi. Yeah. Yeah, we should be right. Okay, so GDB again. Oh, okay. It took a while to load symbols. So why I'm not using GDB multi-arc? Because I don't know how to do that. I will make a note somewhere and I will try to figure out how to do that. I mean, I have several options because I could. I mean, my the machine which is doing the stream and on which I have a terminal is a Mac, and it's a M1 Mac. So I could also do it locally on the Mac, but let's hope that. What happened? Okay, that's great. So it's frozen. Okay, so GDB crashed. So I'm going to try to complete, but not so many. X64 CMD. Okay. ARM64 CMD. What was the function name again? Nope, not here. It's not there anymore. Yeah, muscle is gone. So we are on GNU. We were in debug and depth tract linalg. Okay, let me do the find again. And so tract linalg. ARM64 CMD underscore act. I'm going to hit tab. Okay, that's good. Nope, because I didn't complete all the way. Yes. Okay, well, breakpoint. Woo! Whoa! And so now I'm going to find the test that I want to run. Okay. All right. So I think what I wanted this, yes. And yeah, I can debug GB. Yeah, that's a good idea. This is not what I wanted to do tonight. So let's see what's happening next. Oh, come on now. All right. Okay. So this is a test. Are we processing an empty slice? I think we are not. Okay, so we keep going. We are putting the first instruction address in X5. We're loading some values in the vectors. And if I remember correctly, what we are looking for is a non-zero output. So at some point we must fall onto the unsupported or unimplemented section. X5 is the address of the next instruction. X6 is that instruction. So I want to see X6. Nope, not like that. P X6. Yes. Except it's an absolutely disgusting value. Because okay, so first problem, I think. So our instructions are 32 bits instruction, and X6 is a 64-bit register. It's fine because at the next line we will only look at the 16 less significant bits. So let's see what we find in X7. It should be 10. It's 14. Okay. Let's see. So frame activations.rs. So if done is 0, 0, 1, 2, 3, 4, 5, 6, 7, 9, 10. That was the wrong max. 11, 12, 13, 14. Huh. Okay. What did I do? 0, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. So it should be 15, not 14. Plot thickens. Why 14? Okay, so let's debug Rust sides now. So okay. Let's get rid of this one while cleaning up. Okay, and so so we said that op, yeah, we're testing it right there. Op is 4 bytes. So op has 4 bytes. let's say U8. Sure, I don't think this works. I think I will need a transmute. Yeah. Transmute is in stdmem, I think. Yes, transmute op. And let's just have a look at what's in there. Const 0. There is typo. Yeah, this is a common avatar of using a French keyboard. $14. Okay. So 1400 and 188. So actually op is not, yeah, op. So this is the size of the discriminant. So the ID of which of these we should be in. And so I was thinking that so if I'm trying with tone, it should be 0. So yes, we have a 0 here. These are just random stuff which is not used. So why the hell do we get to 14 and not 15? Let's dichotomize. So mul const. Mul const. Mul const is 12. And max was 10. So 10, 11, 12. So one of these two seems to be erased from the list. I suspect it's because it's never used. But I thought that with the yes, my suspicion, I mean, and it's a certainty now, is that the op is not represented as I thought it would be. And it looks like Rust is skipping some of the enumeration variants because max simple max should be 10. So it's 9. 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's fine, actually. Oh, 10. Okay, so okay, so it's just my initial count that was wrong, actually. 9, 10, 11, 12, 13, 14. Yeah. So I have another case, which, I mean, it's good that it's actually working, because I mean, there is another part of Tract. I mean, the matrix multiplication kernels use the same kind of mapping, except instead of counting it by hand, I mean, there is a mechanism that, and we'll probably do it at a later stage. There is something that parses the right enumeration, and I mean, just to avoid messing up as I just did by just counting the elements by hand. So, okay, so the point is the max const is not 9, it's not 10, it is 14. So let's correct, let's make our assembly code aware of this. So it's not 10, it's 14. Woo! Nope. Yeah. Wrong test. I'm gonna kill the GDB session. It serves its purpose. Yeah. Yeah, wait a minute, because I said woo on an empty list of tests. So let's see what's happening now. Okay, still not good. And kernel function return non-zero 1, still the same error. Okay, so I ran it on the Raspberry Pi, and I used, I mean, it used. I'm looking at, so it's 4B80, and checking if it wasn't strip. That's fine. So 4B80, okay, same than before. So I don't have the history plugged in. Show break ARM64 SIMD act F3232N. Yes. Okay. Layout ISM, or at least run the test name. I need the test name. That's the test name. Go. Layout assembly. So the first one takes a while. I did before. Okay. Okay, so here again, let's test. So now what we have in X7, we have 14. That's good. So we shouldn't fall here. All right, we're going to max const, I hope. Yes, we're on max const. So we're loading in X7, we're loading X6 plus 16. So this is probably not what we should be doing because, oh no, it's not loading, it's a logical shift right. Okay, so we're taking the 32-bit of x6, and instead of looking at the lower bits, we're looking at the higher bits now. So x7 should be all zeros because we are working on the not necessarily on all zeros. Let's have a look, because so max const, we have a constant ID, and the constant ID is U8. So we should have at least one byte of zeros in x7 to the right. $x7, and maybe we have. So we are ending it with this. So let's try again. P(x7). Okay, that's a 0. So we're adding this to x1, which is the second argument. So that's the... Yep, there is an error here. No, there is, okay, left shift less. Okay, so what's happening is I'm computing the address in the table of constant. I'm consting the address of the element number 0. So if the element was not 0, I should skip 4 bytes per element, because elements are 4 bytes. So that's what this does. This is a multiply whatever is in x7 by 4 by bit shifting. So that's cool. It works. I mean, it looks like it's working. On 0, it won't do anything, hopefully. Okay. Computing, adding that to x1 into x7, I should compute a nice address. x7 should be something here. Oh, full, that's fine. And I'm loading this into v24. So v24, v24 0, so in the first element of the vector number 24, and this dup will copy this value in all 4 elements of this vector. So let's do this and have a look at what landed in v24. So the one we are, ooh, nice. It's not working at all. Okay, so there should be somewhere a table of floats. So which one will it be? That could be it. Yes, we have 4 values, and they look like floating point, and they're not zeros, they're something small, no, something, yeah, negative and big, but not zeros. So this is not working. Okay. But problem is probably so I load in the v24 at 0. I'm loading x7. This looks fine as far as I can tell. And where's my mouse going? Okay, it's back. And the dup seems to dup because we are 4 times the same thing. So dup work, but the load didn't. X1. Okay, can I do this. So I was expecting to find zeros over there, and this is not it. So let's go back to the side and see what is happening. So this is where we are running the function, and we have constants as we... Oh, wait a minute. Yes, of course, I know what's wrong. Yeah, I think I know. My test is wrong. Because I think I mixed up the constant IDs with the constant values. And so I suspect max const of alpha. Nope, I do have a constant here of type t. Max const, so type t is constrained by ti, and it has to be f32. So what could it be? Let's try and see here. So I'm going to go where the function is. The function call, and I'm going to see what's in there. Two persons on the chat, and one of them is a spammer. That's great. Yeah, so two of them. Okay. Well, you would have been a pretty good one with big language model and stuff. Big GPT something. All right. Okay, so I'm looking at my screen went black. Okay, it's back. So const are zeros. I just yeah, I think yeah, consts here are zeros. Could it be that I'm gonna have to check the calling convention. Because the other function I'm using, I got lazy with this, and I decided I would have just one argument that would be a structure with all the parameters in the structure. So I'm basically using just x0. Parameter pass in x0 to x7. Wait a minute, this is A64. Okay. Why W and not X? And BTS say that the first argument is spaced in X0, second in X1, and so on up to X7. Our function foo takes two arguments b and c, therefore there will be w and w0 and rho1. Why w and not x? Because there are 32 bits. Okay, so they use w. All right. So I think this is correct. So what if I look at? I have a doubt about the ASPTR, but I think on a slice, and yeah, and it does the right thing on this one, on this guy. So why would it do the wrong one, the wrong thing on the other? So it should not. Okay, let's do this. I'm going to debug constants as PTR. I'm going to debug constant as PTR. And I'm going to check Rust side, I mean assembly side, if we get consistent display. The reference of row pointer, so as const f32. Still the reference of it's unsafe. Okay. I want to check that I'm not using x1 somewhere else. No, it looks fine. Okay, so oh, that's interesting, except it's not. Oh, wait. Okay, so we will do what I was describing before, and I want to know that I'm testing the right thing. So I mean, it can be super confusing with prop test because we don't exactly control what test is running. So because it generates random values and try to find stuff that doesn't work. So in order to debug that kind of issues, I'm going to make there was network error again. Ah putain, c'est pas possible cette connexion. Okay, hope I'm back. should be back. I should be back pretty soon. OBS is streaming. Twitch is not seeing the stream. Twitch is seeing the stream again. Okay, so I'm back. Sorry again for this. So I was saying that using prop tests here and when you try to debug bit by bit is too cumbersome because it generates different stuff at different runs. So what I want to do is what I need is a test that will just test the max const 0. So this is not going to be prop act unit test. It's going to be act unit and actually I want I don't like the way we did this test last time. I don't like it. But I don't want to spend too much time on it either. So I'm going to do something that will probably only work with our test. I mean, yeah, what I can do is, okay. We will copy and paste all of this, make it a different one. So this will be max const 0. And x will be params 0. Okay. Keeping that one. Input 0 line. ty, I still have it. Char, that's fine. Repeat. Just once is enough for this bug. We're going to fill with what was the minimum input. Minimal failing input x0 repeat 1. So repeat 1 is done. X0 that's here. This won't work. I need to do ti0. Nope, it's not working because that's how you do it in macros. Still. Okay, not found for type F32 in the current scope. This will not work for other types, but for now it will be good enough. Max const 0 is defined several times because what? Because yes. I put it in the wrong place. We want it there instead. Okay, params that's alpha, and alpha is 0. Refer 0. So I can get rid of this. Validation tests name. Yes, max const 0. Reference. So that's my test. So it's x max 0. Prog.consts expected f32 found reference vec of integer. Yeah. Max 0 f32. This is very messy. I really need to find a way to unroll this test cleanly, because it's not gonna cut it. But for tonight, I mean, I just want to get this one working. That's the only objective. So test will be refactored later. And yes, also I need to run now a new test. So with this, at least, we have removed of all kind of random and unpredictable stuff, and we should have one single error message instead of 4, because it will just run once, and we will be able to debug and see what is actually happening. Hopefully. And it passed. Okay. Alors, so coming back to so here I have x equals 0, alpha equals 0, which is exactly what I did, because this was x and this is alpha. And we still have an assertion failed. We still have an assertion failed with 1 equals 0. But it's no longer I'm lost in this maze of macros again, because here I am calling the run function, so I'm actually calling the I'm going through the assert. So kernel function return, I have kernel function return non-zero run, so I still have this assert. So there is really something not good happening. Okay, we'll debug again, I guess. Maybe we'll figure it out. So I'm looking for the executable name, so it's 4bad0. Okay, still good. And breakpoint. Breakpoint is here. It's happy. And I'm running with that argument. Here we go. Okay. And all right. What it's doing? N. Okay, entering the function, entering the inner loop. Going to max const, doing the max const, moving back to the end of the loop, adding 4 to x5 to point it to the next instruction, moving back to the top of the loop, loading the next instruction, decoding the instruction, and px7, it should be 0. Ah, it's not 0. Okay. And I know why. Okay. So what is wrong? What is wrong is I am manipulating 64-bit, 32-bit values, but I'm using X register which are 64. And I said before that it shouldn't be a problem actually. But okay, let's make it consistent at least. It won't change anything. That's not it. That's not this. Nope. W6 and W7. Same here. I'm working on just 32-bit values. Except here I'm coming back to 64 values because x1 is a memory address and it is 64. So that's correct. But here that was super weird. So I'm going to add more debug in Rust to see what we are calling I'm going to dump ops as bytes. Can I do this? I think I can do. I think I can do that. Okay, so my assembly is not right anymore. Yeah. Yeah, so this is not, I mean, if I do this, yeah, at this point I can do that because I'm just ending with the last byte. And the problem was this instruction doesn't exist in a form that goes from 32-bit to 64-bit, so that should work. Nope. Where are we? LSR. Okay, same theory. Okay. No, it wasn't saved. Ops as bytes doesn't work, I think. I think we can do something like that on the bytes, on the str as bytes. On, I thought that on a slice std, I thought that it was working on any slice. No, doesn't look like it. We can make it. So come on, as bytes. All right, unsafe. So I'm going to do let op bytes equal std slice from row parts. So I'm taking ops.asPtr, and then I need the len. So ops.len times 4, because I know that operators are 4 bytes long. So these are bytes, and I can display my op bytes. Unsafe. Okay. Unsafe it is. All of this is unsafe, really. Non, c'est pas vrai. Connection is failing again if you're following on YouTube. It's super bad. I mean, it's been like 4 times in 2 hours, something like that. And I don't really know why it did this. Anyway, it's compiling, so people are not missing much, at least. And the one thing is, yeah, I don't know why I did this, and it's when I'm here. Because when I'm at the other place and I'm still using the computer which is standing under my desk, it doesn't do this. So I guess there is something about streaming or the load or something like that. Anyway, so if anybody is back on Twitch, then what do we have now? We have a frozen test, something that never stops. Max const 0. So max const is the one I want to see fail. And it doesn't fail anymore, which is also pretty weird. Not as well as a connection, but still. Okay, it doesn't want to stop, so I'm going to run it without capturing, so we can get an idea of what it's doing. So it shows me op bytes. Ah, yeah, of course. I need to change the type. Yes, that was really bad. Const u8. Pom 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 pom. Come on. Come on, come on. Fail, please. Fail and tell me something I don't know. Surprise me. All right. So, is it surprising? So we have these huge. Okay, so 14,000. That's as expected. So 14,000, that's max const 0, and 00, that's the down. That's the down operator that should get us out of the function. Okay, let's switch to the Raspberry Pi and debug. Function program is still called the same. Yes, for BAD0C. Okay. My break points. Here we go. And run. Okay. And for some reason the output is not showing. That's because, yes, okay, so let's try this again. It's captured. Yes. Okay, so we have this constant. We have 14,0. Then we have constant 0. Okay, so this is a test that is passing, but it should break. I'm not sure why. I'm not sure how we can have two tests unless X is empty. Sure. No. Do not git, but run max const 0. Oh, so except that one is working, of course. Yes, so this one going to work. So if I do continue, yeah, that one is working. So back to max const. So the only so I don't know why the first call never gets into the function. This is weird. It should hit the breakpoint and oh, there are two threads. Okay. Let's try again. Okay. So now we have only one, and the problem is I don't know if it will if it's one of the tests that pass or one of the tests that fails. So let's try. We're jumping to max const, yes, doing the max const hopefully. Then back to inner loop, moving the instruction pointer. So, oh, we are moving it by 4. No, we should move it by 2. Instruction are 4 bytes. Yes, instruction are 4 bytes. 2 for the opcode and 2 for the payload. So no, that's correct. Next, inner loop, we should fetch, decode, find a 0, and jump to we did not stop. Oh yeah, that's this value again. Okay. Okay, and if I yeah, we're jumping to unsupported, 0, return, blah blah blah, we're dead. Yes, we're return and we're dead. Okay. So where do we get this 6.5 value? We bytes. That's some, no, it's, yes, I know. I think I know. I mean, it's going to be stupid. If this is it. So, I mean, the problem is, so operator is 4 bytes long. Yeah. So opcode is 2 bytes, but operator is 4. And here we had 4 bytes. So we only have one operator, which is max const. And we should have max const plus down. And I guess that my problem is just that here I forgot. Yeah. Told you it would be stupid. Damn. So the assembly was correct. I think the only thing I changed in the assembly is the branch that was missing at the very beginning, and the rest didn't make any difference. Because I think these changes are actually not making any difference. Oh yeah, so yeah, so that one and this one, the rest probably doesn't change much. And lots of debugging. I mean, I'm just assuming that it will work. Oh no, it's not working. Okay, mismatch, wanted approximate. Okay, so that's different. At least now it looks like we have the right sequence of operation, and we are going through where we want to go. But we're not getting the right result, which is also a problem. So I'm trying to figure out. So it's still x equals 0, repeat 1, alpha equals this big number. And that's the simplest that it finds. So what should I do? Should I try? Yes, I should try to do a simple test, a non-prop test with this magic value tests, and yeah, this is so not right. So the value we want is as alpha this awful thing. Max const. Okay. Max const big alpha. I'm gonna be right back. I need a glass of water. Okay. Wanted approximate 0 blah 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 is different than 0. Yes, it is. And okay. So I'm doing expected. The left is expected, and should we debug this? What should it be actually? What should be the result? 0 max, a big value should be the big value. So if input is 0, then it's wrong. It should be the big value. I'm not too sure. Okay, let's debug again. Still BAD, yes, for BAD, blabla. Donc, the breakpoint, I must have it somewhere. Looking for the breakpoint. Nope. Break. Key. And run. No capture. And it's not. It would be max const. Max const what? Max const big alpha. Okay. So does it make sense? At least we have the max const. We have this value, the 247, which we can ignore because so the two first bytes, 14 and 0, make the opcode. So 0 is a constant ID, so it's the first constant, and it's a 1 byte, and the 247 is just padding. I mean, it's not read, hopefully, and this is a dawn, so that's correct. Layout assembly. Okay, let's go through it again. So we shouldn't be done. We are decoding. Not done. Okay. Going to max const. Yes. Loading our big value in and duplicating it in v24. If I remember correctly, nope. psv24.f. Nope. Okay, I don't remember how you do that. But it's there. So we have our big value. That's good. Let's have a look at what we have in v0 now. SV0 dot nothing. So we have all zeros. Should I check the 8 of them? Maybe I will check the 8 of them, just to make sure, or at least. Okay, so, well, the two first and the last are correct. But when I do this, I should find in v0, I should find the big value, which I do find. Checking that 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, 24, 24, 24, 24, 24. Looks good. Okay, let's check that we have the big value. Oh, is it this? No. V7. Ha! Oh, yes. And now we should have it. V7. How big value? Yes, it's over there. Okay. So we should jump to the end of the inner loop. Move the instruction pointer by 4. Go back to the beginning of the inner loop. Decode. This should be 0, so we should jump. And so, yes, we are storing. We are storing all our values are in the right place. The instruction looks right. This one looks right too. We're moving x2, we are subtracting x3, and we should jump to OK. So next should bring us to the next line. Yes, and now we should jump to OK. All right, we're recovering our registers and returning. OK. And it did fail. So, and it did fail. So I'm passing, this looks fine. Let's have a look at what's inside. Because one thing that it doesn't say, well, yes, it does. I mean, at position 0, so at the first, even the first value seems to be wrong. So let's check it explicitly. Expected. Okay, running again. I want to check, do we have the right value in the constants? Yes, constant is fine. Well, anyway, it's fine because the computation was working correctly. So input is still it looks like we are not storing the results back. Okay. I'm trying to remember if there could be something weird happening here, but I don't think so. This will just actually, yeah, give us a mutable slice inside the tensor, the input tensor, so it should work. Okay, let's have a look at our storage bit. Nope, it looks good. It looks all good. Okay. Let me just have a look at some other storage instructions, see if I can spot something stupid with these ones. Nope. No, these look the same. We are looking at that's just to store one lane, but I want to check what ST1 is doing, but so interestingly enough, it doesn't look like there is the variant that we are trying to use, where we have several store single one element structure from one lane of run registers. One lane of run registers. Maybe that's wrong actually. So I mean the load and store are. Oh yeah, but we still have this one. So 4 registers. with accent. That's the one we're trying to use. Store multiple one-element structure from 1, 2, or 3, or 4 registers. And that's exactly the one we are doing. So VT, or that one, no, that one, I mean this one and that one. VT is the name of the first or only SIMD or FP to be transferred. Okay, so I'm transferring 4 of them. 1 register immediate offset. 4 register can be 1 of 32 of 64 depending on the size. So we are using 64. So our arrangement is 4S. So, oh, wait a minute. Oh yes, 1 register, but we have 4 registers. So 4 register, 4S, and it's 64. Okay, so that's correct. Nothing fishy here. X2, X2 seems so we're moving the pointer, but that shouldn't affect the outside code. We're not using X2 anywhere else. Max const doesn't touch X2. Okay, or W2, no, that's fine. Okay, so let's look Rust side at the address where, to be honest, I thought it would be. I didn't think it would be so difficult. So no, I'm looking at the tests, activations tests. So big alpha, that's my test, and I want to see. Let's see debug input as pointer. I do have something like as bytes ptr maybe. Nope. There is a method on Tensor that just returns the address as a pointer to U8 bytes, fn bytes. It has to be unsafe. Does it? Not sure. Sign. Close enough. Into array, to review. As ptr unchecked. Oh, can use this one anyway. As slice mut. As slice to scalar, scalar as bytes. I knew there was as bytes. Just that it's unsafe. But it's not like the rest is anyway. So this will show me the... No, oh yeah, it will show me... What I want is a pointer. I want to check that the address here and the address that I'm writing to in the assembly are the same. And I want to check that here the address doesn't change, which I shouldn't. No, that's correct. Sorry. Thought it might have been an alignment issue, but no, it's taken care of already, so I don't think so. I'm trying to suspect that this is wrong actually. So it might be Rust side because if I'm taking input as slice mut, then I have my slice mut. So why did I put this ampersand mut on top of it? SRC. Where am I? I mean on top level. Okay. Active SRC frame activation. Activations .rs. And I'm looking at the run method. So it's taking a vector of t. No, it's not the right one. This is the Rust function. This is a kernel function, so it's in activation care. So this is a one, so it's taking a mutable slice of t's. It should be this. And it's compiling. That's the beauty of pointer. In Rust as in C, you're losing so much type safety. Still no cigar. So we are looking at big alpha. Yes, the one I changed. Okay, because I haven't fixed. If that is the bug, I haven't fixed the other guys. Stop. And I need to check. So we still have zeros. This looks like it's our address. So we're going to test it in assembly. But before this, I need Come on. Okay. Yes, we still have. What I wanted was as const input. Whoa. Let's take it calmly. So constant. So that's my input. As bytes, okay, all zeros, absolutely nothing to see. Okay, I have my address in X and in numbers, in decimal. So assuming we are still using the same binary for BAD, okay, let's go. Breakpoint. Run, no capture, and also single thread, please. Okay. So we have the address here, and I don't know if I'm not sure I need the okay layout ASM. Storing, loading values, decoding instruction, max const, yes. Checking whatever is in v7.v7. We have the big value, okay. Let's keep going. So we're moving to next instruction. We jumping back at the beginning of the loop. Next instruction, we should go to yes, we should jump. We did jump, and that's where we're storing. So what I want to see is what is in x2, and compare that. And I'm not sure how I managed to do this. Let me do that instead. Oh, it doesn't want me to cut and paste. So it turns in 278560. And yes, bingo, the address was different. Okay, so we are not writing, we are not getting the right buffer. The pointer or something is wrong. Okay, interesting. And we were looking at this one. So what is it doing? It's calling the run method on src frame activations .rs. So we're getting into the run function. The run function which is defined in the macro here. So this is useless. And verbose. This looks good now, so let's get rid of it. This seems finally okay. So buff as mut pointer. Buff as mut pointer. Let's have a look at what it contains. Buff as mut ptr. and it should be the same as this one. I think we are done with this one. Still pretty long to copy this binary over. Okay, it's done. Max const. Let's stick with big alpha. And so we have one address here. This guy has the same address, same as this one, but somehow this is not what we get on the other side. Let's check again. For BAD, yeah. For BAD. My breakpoint. Breakpoint. Run capture, single thread, blah blah. Okay. We have this address again. I think it was the same than the run before. Can I? Yes. Except I no longer have it as unsigned, but that's fine. Okay. Okay. Doing the max. Blah blah blah. Decoding. Going to end of loop and checking what we get in x2 28 14 64 28 14 64 70 82 78 70 82 78 496 nope that's not x2. What we get in x2. Okay. What the hell? So here I'm looking at it right before we call the function. I mean, it's buff as mut.ptr and buff as mut.ptr. So these two hopefully will be the same. To make sure of this, I'm gonna move this around here, but really I don't think it will make any difference. 78 496 78 56. So either any place where we are touching x2. I don't think so. So we're going to run again and check x2 right when we get into the function. Okay, so I want to check x0. So x0 is address of first operator. Not super interesting. x1 is address of first constant. And nope. And px2 496. Ha! Here is our 496. Oh! I know. I know. I know. I know. I mixed up the syntax. So let me explain that. So this is why it happens. Or rather, this is why it happens. So x2 is actually changed here. This syntax will read 64 bytes into these buffers, into v4 to v7, from the address x2, and then it will move x2 by 64 forward. So that way, if you want to read several, if you want to read in sequence, then you don't have to read and then add 64 to the to your pointer. Except this is not what we want to do here. In our example, we are actually managing x2 separately because we don't want to change x2 here. Because we are going to reuse it again to store the same place. What I wanted to do was this, except I think this syntax, so this syntax, if it exists, means read adds x2 plus 64, but do not alter x2. But I don't think this syntax exists in vector loads. So sometimes it's with a comma, sometimes it's with a plus. This assembly memory instruction are super confusing. Let me go back to, I think this was a calling convention. Yes. So that was the other one. So so this is post index. Post index means read, then move the pointer. And we checked before that I was actually moving the pointer by the right dimension, but so no, we cannot do this. This doesn't work. There is no way to write this in ARM64. So what can we do? We can use another register. Like for instance, x4 is free. I think we're not using it anywhere. That's right. So we are going to I need to do this. I'm going to do it this way. So if I'm doing this, then at this point, x2 has been offset by 64. So before I'm storing in x2, I need to sub 128 to x2 to put it back where it was. I'm going actually to do it there. And here I can use the regular syntax. And that way, one issue fixed more, and I hope that this time it will work. Suspense. It did work. Ouh, ça y est. Okay. It's been a bit of work, but now we have a minimum vertical thing working, so the rest can probably be worked out pretty quickly. What I'm going to do is I'm going to clean up this because there is one more thing I want to do before calling it a night. So I want to get rid of all the debug stuff first. There's none here. So there is some here everywhere. So first of all, we said that on the run, this mute apparently was not a source of a problem, but it doesn't make sense, so I'm getting rid of it. I need to figure out a way to factorize this code more to get the test nice and easy to write, because I will want like, I mean, yeah, I will want a lot of them. I want to check, basically I want to check that every single operation defined in the VM will run correctly, and I want a prop test on each of these. So what we did for this guy, I want to do it for all of the function, and I want it to be, I mean, I want these things to be like a one-liner or something like that. I don't want to cut and paste 10 or 12 lines every time I find out a unit test that I want to keep and name. So it's still working, so let's get rid of a bit more debug. Okay, we are going to switch back to QEMU because it's faster. QEMU arc, compiling again. I think there is some debug left in activations.rs. If I remember, yes, that one can go. So this one on early debugging, it's commented out for now. I think we can get rid of it now. We understood what was wrong. It looks like we no longer have sporadic output, so that's good. There is something I want to try. I think after these 2 or 3 hours of staring at this code, I spotted a simplification. So yes, that's the place. So basically all of the operator implementation, like max const, jump to this place, then we add 4 to x5, and then we jump back to inner loop. But if I'm moving this, so here I can do actually that, and I can get rid of this, and I can get rid of all that, and here I can jump to inner loop. Yes, okay. So that's a bit less of noise. Okay, well, I think I'm going to commit this and call it a night. It has been more chaotic than I hoped for. Looking at what we actually learned or fixed in the assembly code. So this is just simplification I just did right now. We change the reading type for we change the reading type, but it doesn't make a big difference because we are doing bit mask, so we are really looking at the right bits. So I don't think there was a bug here. We fixed the x2 management code. I'm thinking actually, no, it doesn't change anything. I was thinking there was another way to do the address management, but at least this one is easy to understand. So there was this jump missing and we were just falling into the max count code. I think this one is free. That is just simplification. So here that's just comments. We improve log message. And we fixed that test because done was required. And that's about it. So we really absolutely need to find a way to factorize this terrible test case, because there will be like dozens of them when I'm done. But yep, that's not too bad for tonight. At least we have really working. That's one. So I'm going to stop there. I'm going to upload the full stream to YouTube right away. So if you don't feel like you have had enough, and if you want to see all of it, including the time where I was ranting against my connection, then well, feel free to. And maybe I will be back tomorrow night for the next to keep going on that. Bye everyone.